In today's video, we will learn how to analyze floor flatness and levelness based on your 3D scan data using ARES Commander and Undet tools. The first step to start analyzing floor flatness is to slice point cloud points to see the floor area and remove all unnecessary points. To do that, we will use a clip by rectangle tool, and as you can see, I can very easily and fast hide the points which I don't want to use in this analysis. Once we have a clear view of the floors, we need to select coloring mode by plane, and in the settings we need to choose color palette with the fixed intervals and activate fixed size coloring mode, and let's try 1 centimeter intervals. Now our point cloud is colored by plane, and each color represent as different level, and now we can see some deformations in our floor plan. Okay, so now let's try with 5 mm intervals, and we can clearly see that there is some deformation in this floor area. Once we have point cloud colored by plane, now we see deformations visually, and we can start annotating this floor plan drawing. To do that, we will use snapping blocks. If you don't have these blocks, feel free to contact me, I will share with you what these blocks are doing. So if I selecting block, I can type position Z value, and it will automatically show this value in the attributes. So we will use these blocks, snap to the point cloud points by inserting it, and to show exact Z values of each point cloud points where we will place that. To copy this block, we will use copy with the reference point tool, and we will get back to our main DVG file, and by pasting block we can snap to the point cloud points using Undet snapping tools. When Undet point cloud snapping is activated, we can select snapping mode to the nearest point, to the highest point, to the lowest point, and search limits. Let's pick snapping to the nearest points, and once the block is placed to a point cloud points, it will automatically show the point cloud point Z value where we snapped this block. And later on you can use copy tool to copy this block and place this block to different locations to show each block Z value of your point cloud points. Also, we can use coloring mode with transparency, and in this case you will see the point cloud points and the blocks which you placed more clearly. In this video part, we will learn how to create the grid of that snapping blocks and automatically drape these blocks to a point cloud points. So first of all, we will select single block which we have inserted in our drawing, and we will use array command with 2 meters of interval. We will create the grid which will cover the area where we want to have the grid, and by using move we can just place the blocks where we want. Of course, by using grip here we can adjust the grid area, how many blocks we want to use. Once our grid is set up, we will explode it using explode tool, and now each block is separate, and automatically drape these blocks to a point cloud points. We will use draping tool, drape polyline tool, and by using this tool we also need to select how we want to drape our blocks. We can set search limits, let's say centimeters, and we can select the option how to drape our blocks to the lowest point, to the highest point, or to the area where is the highest density of a point cloud points. So in this case we will select option L, lowest points, and now by selecting all blocks we will press enter, and now the software will automatically drape all blocks to the point cloud points. Once it's ready, after updating your drawing, you will see the grid of undet snapping blocks, which each blocks showing the point cloud point value as attribute, and we can estimate floor flatness only by these values. Now let's talk how to generate the heat map of this floor area. When we have set up the coloring by plane with the intervals which we want to use, we will use ortho tool. We'll select the resolution, rendering source of full resolution, and we will select the area where we want to have an image. And now we have the 2D image generated from the point cloud. We can hide point cloud points. We can select the image. We can move, activate the point cloud points. It is how easily we can create the heat map to show the floor flatness. And in the last part of this video, I will show you how you can compare your design surface with as-built point cloud. So as you can see here, I have 3D solid model with our floor design level, and to check if design fitting with as-built point cloud, we can use model inspection coloring mode and select coloring by faces, and in the settings we can select the tolerance, design model or projected surface. Let's select 5 mm, and as you can see, now we can see that only few areas of the point cloud points are fitting with design perfectly, and most of the area is not. And of course, you can generate the heat map, you can place some annotations blocks as I have showed in the previous part of this video. I hope this information will be useful for you to analyze the floor flatness and levelness and generate reports for your customers.